Actually be live. Hello, everyone. We should be live now. And we're going to give it just like 30 seconds or so as people start joining in and just making sure that our streams are going. If people are already here watching, I think there's already some people here. Feel free to throw in the chat, say hello, maybe say where you're watching from is kind of fun. And if you want to throw in anything more interesting around, maybe why you're interested in learning more about computer vision models, that's really fun as well. But at least I think it's fun seeing like, hey, I'm from wherever. I'm watching from Seattle, or I'm streaming from Seattle. And Harpreet, where are you streaming from today?
So I live in Winnipeg, Canada, Winnipeg, Manitoba, Canada, but I'm from Sacramento, born and raised Sacramento my whole entire life, uh, but been here for the last almost 10 years.
Nice. I think I've been in Seattle for like 8 years, 9 years. So at this point, I just say I'm like from Seattle, even though I moved
Yeah.
here a while ago. But at that point, you're like, oh, like when do you? I'm not like natively born here, but I don't know where that line is when you say, well, I moved here like 8 years ago. At that point, it's like this is the longest I've lived somewhere since I was a kid. So
Yeah. Just claim it, man.
Kelsey said, watching from Seattle. Harpreet wrote in the comment, "What's up, everyone?"
Yeah.
Yeah, and we should
I'm
be
trying to.
streaming on YouTube and LinkedIn. I know
Awesome.
on YouTube, I have a lot of embedded links for all of Harpreet's social, as well as some of the, I think, products we're going to talk about. So check out those links in the description. And all right, so I'll just do a quick intro, and we'll get to some questions here in a second. My name is Sage Elliott, and I'm the host for today's Robust and Responsible AI event. We're a community of AI and machine learning practitioners, researchers, and much more. Really, it's people all around, like designers, etc., working around really cool AI products. And this style of event, you can think of kind of as a live podcast. So we'll be interviewing guests. Today is Harpreet, starting with a specific topic. So today we're going to be talking about computer vision and some ways that you can think about potentially building better models. And we might have some time for questions. Feel free to throw them in the chat, and hopefully we'll get to them. And I always like to say, if you have an interesting story to tell or something you want to talk about, ping me. If you want to come on for a live stream, you can do that on LinkedIn is a good way, or we have the Robust and Responsible AI Slack channel in the description. And today we have our guest, Harpreet, who's going to talk about building computer vision models, or how we can do that in some better ways. It'll be fun. I think we have some good questions lined up. But before we really get started, can you tell us a little bit about yourself and let us know, like I like hearing kind of an overview of your background and how you got interested or started in the data and machine learning field. And then maybe just like a little bit about what you're currently working on, and we'll go deeper into that a little bit later.
Yeah, for sure, man. Well, what's up, everybody? Happy to be here. Hope you all are having a great day. So, my background, like, I'll take it back, dude. I'll take it back to the fact that, dude, I didn't actually graduate high school. I got kicked out of high school during my last semester, which sucked because I was an honor student and I was like, going to go to some great schools, and all those uh, got those acceptances all got rejected and pulled. But I did eventually get my act together and went to community college and studied at Cal State Fullerton, where I did economics. After that, I taught math for a few years, and I taught math at high school level for like what was called academic recovery. So these are like kids that got kicked out of high school, maybe even went to juvie, got out of juvie, and whatever. Academic recovery is pretty much it. And that's kind of where I discovered like I really enjoy math more than I thought I did, and I decided to pursue a career in it. So I was like, all right, cool. What's like a career that makes money using math? And this is 2008 or nine at the time where I'm like Googling this, and it was actuary. And I was like, hell yeah, I'm going to be that. I'm going to be an actuary. Great. What do I need to do to be an actuary? Well, shit, there's a ton of math and like graduate degrees. And I didn't have like mentors and stuff, so I didn't know who to ask. So I just did the naive thing where it's like, just go to grad school and do it. Long story short, there's a lot more to that story I'll cut out. Ended up going to grad school, graduating, was an actuary for like a year and a half, then became a biostatistician for about 5 years, transitioned into data science. In 2018, I was got my first data science job as like a senior data scientist. Then I was a lead data scientist. And so up until that point, just really well versed in like classical ML and statistics, of course, and all that. And in 2021 is when I pivoted into developer relations. And since then, worked at Comet, Pachyderm, and now at Deci. Um, this kind of coincidentally incided with like my interest in deep learning when I, became a developer advocate. So yeah, long story. Try to make it as short as possible for y'all.
No, that's great. Quick other question on there, because I know you've also done a lot of mentorship and helping people kind of get started in data science or learn data science. Do you have any quick piece of advice maybe for people breaking into that field or deep learning, for example, if they wanted to get started?
Yeah, I would say just don't blindly say that I want to be a data scientist because I think now more than ever nobody really knows what that means. So instead, just think about, okay, what are the things I want to do every day and find roles that align with that and develop those skills. Like if you're like the type of person where it's like, dude, I just want to, I want to get in the data, I want to find insights, I want to create narratives, and go be an analyst. If you're the type of person that's like, all right, cool, I got this data, I want to run experiments with it, I want to try to enhance product offerings, whatever, then be like a traditional data scientist. If you're somebody that's like, all right, I love cutting edge research and I want to learn how to take that research and take it from just math and equations into code that then produces an outcome, then go be like a research scientist or a research engineer. Right? If you're interested in then taking these models and then saying, all right, I want to take these models and then actually build products with them, then go be an AI engineer or machine learning engineer, right? So just get clear on what it is that you want to do first and foremost, and work backwards from there. I think that's the biggest piece of advice. Just don't say generically, I want to be a data scientist, because you will be in for a world of pain.
Yeah, I think having a some sort of personal project that's interesting for you helps a lot. Even if you do pivot later, like I know a lot of people get started and they do something with like sports data because they're really into watching baseball. And then later on, they might not work for a baseball team, but it's such a good start for them, like digging deeper and learning how to clean that data. And then we'll move on in a second. But also, I wanted to tack on also, what is or I was going to say maybe what is a developer advocate, or how do you like being a developer advocate? I've also been one now for several years, but what was that transition like going from a data scientist into the developer advocate type role?
Yeah. So developer advocate, developer relations. I say like developer relations, like the umbrella term. And then within developer relations, there's like these different roles: developer advocate, developer experience engineer, community manager, so on and so forth. And I found myself kind of in this role back in 2018 when I was part of like Data Science Dream Job. And at Data Science Dream Job is like this course slash community for people trying to break into the field. And my job there was to create technical content, manage the Slack community, answer questions, host office hours. Um, and I think I already mentioned like create technical content to continue education for people. Um, and so like I found out that that's actually a full-time job that pays a lot of money. That's like a good paying job. And I was like, wait, hold up. All the stuff I'm doing on the side is like actually someone's full-time job. Um, and so it was just a natural fit for me. I was able to find a way to combine my vocation with my avocation, right? So like the thing I like to do and the thing I do are now the same thing. Uh, so I've been loving it.
Yeah,
But
that's awesome.
I don't know if that answered your question at all. I
No,
don't
I
know
think that's good. Yeah, I just was curious, like how the transition happened and how you like it. And yeah, just I hear the same thing from many people, and myself included, where it's like, oh, I'm just already like organizing all these events or doing these types of content, and then someone's like, hey, did you know that's a job? And I'm like, no, I did not know. All right, so let's get a little bit more into the actual topic today, which is building better computer vision models. But before we go down. Maybe some of the examples you've seen for how to build a better one. How did you kind of maybe get into computer vision? And was there something that you thought, oh, like this is really interesting, like where you kind of like saw the power of these types of applications?
Yeah, so I think the first natural step after learning about, okay, what is a neural network, what is like a multi-layer perceptron, and what's happening, computer vision is like the thing you'd move to next, right? Because that's naturally where deep learning kind of kicked off, was in the field of computer vision. I'm not like a super expert on computer vision by any means whatsoever, and really my interest in computer vision started when I was at Deci, because Deci historically has been in the computer vision space, like building tools for computer vision engineers, building models, computer vision models. So really, that's kind of how I got into it. Was just a little over a year ago, and just went right in, and started with classification, and just not only that, but just like the rich history of computer vision. Really got exposed to that last year, and kind of before I was like, what do all these terms mean? Like, what the hell is a ImageNet or a ResNet or a AlexNet or a LinNet? Like, what are these things? But yeah, started figuring that stuff out just about a year ago, and been on it ever since.
Yeah, there's all sorts of different nets that you can use
Yeah,
depending on which application you
yeah,
want. And yeah, I think most people probably starting with deep learning probably do quickly go into computer vision classification. I think that was my experience too. Like going through any courses and stuff, you build a neural network that does some sort of numerical prediction on tabular data or something, and then quickly they're like, all right, here's the MNIST data set. We're going to
yep,
build a,
yep,
a convolutional neural network. And just
yeah,
for anyone already watching, um, what you could put maybe a little bit of your experience of like how you learned about computer vision in the comments. That would be interesting. And
yeah.
yeah, I'm excited to dive more into the stuff Deci's been working on or some of the challenges around it. But first I was going to say, are there any applications of computer vision that you've seen right now that you find pretty interesting that kind of gets you excited? Like there's so many applications I see all the time, like in healthcare or like agriculture. There's like in Seattle, there's a startup that's a robot that drives around with computer vision and kills weeds with lasers, which I think is awesome.
Yeah, I do. I think like I'm most like fascinated by just like the subtle little things that you might overlook. I mean, at least I was overlooking it before I realized that, oh shit, this is computer vision. Like, for example, the beautiful touch-up feature on StreamYard that is helping me not look so old, right? Like right there, that's an application of computer vision. Or if I go and I blur out my screen, right, that is segmentation working right there. That's a computer vision model working right there in the browser, which is like mind blowing, right? Um, just little applications like that, portrait mode on iPhone, right? That's also segmentation. Those little like everyday things that we take for granted, I find to be super interesting. But I mean, beyond that, just the multimodal stuff has been fascinating, right? Like there's that paper that came out. I haven't read it too in depth, but I read the blog post like image bind, for example, right? There's combining 7 different modalities into one embedding space. And the one thing that they are using to tie all those different modalities together is the image, is vision. So it's kind of like at the heart of everything. But yeah, foundation models and computer visions have been pretty interesting. Promptable foundation models or promptable vision models. Yeah, those are like the things I've been just enjoying.
Yeah, the promptable or like using natural language to interact with computer vision models has been really interesting. I think that's gonna blow up probably, I don't know, this year even or next year. I mean, I already see a lot of cool stuff around it, but I'm
Yeah,
sure someone's going to have the right application and the right kind of marketing behind it to really make that blow up probably in this year or something like that. But it's so cool if no one's tried anything like that yet. There's some tools where you can have an image and ask a question about it, and get a result, like stuff like saying um, is there a dog in this image, or and maybe that seems a little mundane because you already Google search that or something, but more specific things like is the person wearing a hat, and you put in
yeah,
the image of Harpreet and it's like yes, like all these interesting like queryable results with image models, which I think is going to be really exciting and probably a lot of interesting stuff for like robotics as well with that application, I can imagine. But I also love what you touched on about how there's all these like small little models out in the world already that we're probably interacting with every single day and you might not even realize it.
yeah. Yeah, speaking about like those promptable models, I don't know if you know Peter Skalski from RoboFlow. He has like a great video on the RoboFlow channel where he's exploring segment anything, and
Mm-hmm.
he's prompting the model to do like little things that is just picking up on. For example, like highlight the handle of of this coffee mug on the table, and it's like able to do that. It's mind blowing.
It's so cool. And as someone who I used to work a lot in the computer vision space and also around like I've done a lot of data annotation, worked on data annotation tools, having that segment anything model ready, and like you're saying that you could query like, hey, highlight and basically annotate this thing for me, versus you manually having to draw around everything, is
Mhm.
super exciting. Because I don't know if
Yeah,
anyone's done a lot of data annotation, but it's not the most fun work usually.
and it's great to have tools like that that are going to help improve data set quality or just improve the speed at which we're able to label and annotate stuff, right? If we
Yeah.
can augment humans to make that job easier, hopefully the result is better data sets. And better data sets obviously means better models. But just also just think about stuff like, exciting stuff that is happening in the future. I've been reading this book, AI 2041. Have you heard of it?
Um, is that the one where it's like a whole bunch of little stories, basically?
Yeah,
Yeah,
yeah, yeah.
I've started that as well, actually.
Yeah, it's really good. And just thinking about it, it's by Kai-Fu Lee, who's like actually like worked at like Google and Meta and Apple and got a PhD. So he like knows his stuff and he's grounded in reality and he's projecting 20 years forward these scenarios where deep learning and AI are kind of gonna go to. But just like the wearable headsets and things like that, right? Like that I guess transition from just classifying images, drawing bounding boxes around objects, and prompting models to highlight stuff to then, okay, this stuff is like now we're wearing it and we're using it to augment our reality or extend our reality. Those type of computer vision applications, they're starting on the stuff that we're working with right now. So it's crazy to think about.
It's fun looking back at some older sci-fi books, and you read about an object or something in there, and then you say, well, we have that today. Like you're talking about a
Yeah,
digital newspaper or something, back in the 60s or whatever, and you're like, oh, we have that. And so it's like fun seeing stuff like this where you're like, oh, we have seeds of that right now. It's not
yep,
like everyone's wearing those headsets all the time yet, but we're probably getting pretty close. And yeah, Kai-Fu Lee is really cool. I also read his previous book, I think it was AI Superpowers. Definitely a good read. If you haven't read that one, he's a great author. And yeah, I'm excited to go deeper into this book because it's pretty interesting. I think he, like you said, he is really knowledgeable on these subjects, and then I think he partnered with a sci-fi writer to write
yeah,
these like
yeah,
scenarios. So it's a real
that's
fun
right.
piece of like sci-fi, but it's all based on like real stuff that we're developing now, which is pretty
Yep,
interesting.
yep,
And I think some of what we talked about here, especially around like the data quality and data labeling images, ties really well into our next question, which is what are some of the common challenges when it comes to building computer vision models? We already touched on data labeling and
yeah.
data quality, and I know we'll probably go deeper in this a little bit later, but I know like Deci has been working around some tools to tackle these challenges that you might run into when building computer vision models.
Yeah, yeah, like I've been recently just collecting a lot of feedback from users of Super Gradients, our open source training library, and just getting like one on one with them and just chatting with them and trying to feel their pain points. And like uh, you hear it and you just kind of take it for granted. And you're like, oh, it's just a marketing term, like the data centric AI. Like Andrew Ng says it, and now all of a sudden everybody's saying it. Like, and I just kind of get immune to it when I hear it or see people posting about it. But then when they're actually talking to people, actual practitioners, and like that's the thing I keep hearing is like, you know what, like the actual model, like I'll just choose whatever, like whatever's small enough for whatever's meeting the memory footprints, the latency requirements, and accuracy. Like it doesn't matter. I'll choose one of those. And the thing that does matter the most is actually a good quality data set. So just hearing people actually say that is true. Yes, testament to the fact that's true. Yeah.
Yeah, I think it's a big part of obviously training your model and getting it to work correctly in the
Yeah.
application is having data and quickly, like I one of the best ways I found too to help with this, and I hope more people are doing it, is to quickly put a model in production in some way, even if you're not actually using that model to make decisions for the end user or anything like that, but then collecting that production data very quickly, and then potentially annotating that new data that's actually in production and
Mhm.
training your model and then deploying that new model out has been a really good way of helping to make sure that your data set's actually aligning with the current state of like your production environment. So sometimes you might get data that's like 6 months old or something as well, and then the seasons change, so now it looks different in production. There's snow on the ground or something like that, very different than the data you had. And quickly putting a model in production has really helped with that from what I've seen.
Yeah, yeah. And your other question was choosing the right model. How do you go about choosing the right model? And I mean, I think there's a shout out again to Peter Skalski. He talks about how to choose the right object detection model. So go look at his video on RoboFlow about that. But in general, like just pick one model, right, and consider that your baseline. So if you're doing classification, then maybe just quickly take a ResNet and use that as your baseline, and then go more complex from there if you need to. But just think about the deployment environment that you're going to be working in, right? Like I think that's probably the most critical thing to consider when choosing a model, right? Is if you're just sending stuff to and from the cloud, then maybe you couldn't go with a larger model with more parameters and you know work with that. But if you're deploying something like on a device, an edge device, or in a browser or something like that, then you've got to go with something more lightweight, less parameters, right? So maybe efficient net or mobile net, and then use that as your baseline, and then just go from there. But the important thing is just choose one because really the data matters more than the model. Choose one, get some baseline results, and then go from there.
Yeah, and I think that's true for so many data science or machine learning applications. Like choose a model. Maybe it's not even going to be the perfect model yet, but you start getting a baseline, and then you have something to improve upon.
Yeah.
And like you said too, know where you're going to be deploying that model is a great factor in when choosing one. So, you might not be able to run all of Llama 2 on a Raspberry Pi or something like that,
Yeah.
but maybe you can. I
Yeah.
don't know. I doubt it. But you might be able to run like a fine-tuned version of Distilbert or some other computer vision type model, and be able to put that out, and you might get decent results or as good as Llama 2 in your certain situation. But yeah, I think having a metric that you want to measure, like is it classification, is it object detection, etc., knowing where you're going to deploy it, and then also knowing maybe a little bit about how quickly does your model need to act? Like what is the acceptable latency issue? Like, is it a device on a self-driving car where it needs to make a decision immediately, or like you said, can it be a cloud model and maybe you can just send some data 15 minutes later and that's fine?
Yeah, that's excellent point to bring up because I think a lot of times as people who are building models, we might get overly fixated on just one metric, right? And maybe you're just looking at, I mean, I'm sure more advanced practitioners are looking at more complex stuff, but when you're just getting started, you're most likely just looking at the accuracy over epochs, right? And that's great. You might build like a really accurate model, but then okay, it's time to deploy it, and maybe you're deploying it on I don't know like a Jetson Nano, or maybe you're deploying it on one of those Oak D whatever devices, and you come to realize that oh man, like model footprint, the size of this model does not even fit on the device I have. So what do I do from there, right? And then from there, having some tricks in your belt, like maybe do some pruning or quantization or something to kind of reduce that memory footprint. But the point I'm making is we get so fixated on that one metric that we don't even plot against the other one. So it might be good to plot accuracy versus latency or accuracy versus throughput. And latency, just to be clear, is like the time it takes a model to make a prediction. From the time that I give the input to the time that I get the predicted output, right? That's latency. Then throughput is how many predictions can this model make in a given time, right? So these are things that we need to be considering as well when we're in the lab and measure them. Um, you know, you could have a great object detection model, but if it's not, the frames per second aren't enough for you to even make a decision. Like it's lagging too slow.
Yeah, it all is like comes down to the application kind of what you need. Someone asked a question about is there any research going into using computer vision to identify cancer cells and kill them selectively? I know I've seen a lot of um, I don't have any specific paper in mind or anything, but I know there's a lot of research on it. This isn't probably either of our fields of
Yeah.
specific cancer treatment with computer vision, but I know I've seen a lot of stuff in terms of like identifying it. And there's been a lot of research around it. I don't know then what the treatment is from identifying it, but I want to say I'm sure there's some really cool stuff going on, but I don't have anything
Yeah.
specific to link out.
Yeah, dude, I think we take it for granted that really deep learning has only been around for like 11 years. Like we're still
Mhm.
really early stages. So I mean, yeah, I've seen like data sets on Kaggle where it's like classify whether this blood cell is cancerous or not. Okay, that's fine. I've seen uh data sets on Kaggle where it's like actually like outline, cells that are cancerous or whatever. So can we detect them? Yeah, but like actually using it in this type of environment, I think is like really tricky.
I think the treatment, yeah, and again, not my
Yeah,
field, so I don't know how they
yeah. I'm
specifically
not gonna.
target something with treatment
Yeah,
from identifying it. Like that's a much harder problem than the weed laser robot that we were talking about that could just shoot
yeah,
lasers at
yeah,
weeds. I don't know how
yeah,
you how you would do that with a cancer cell. All right, moving on. So we talked about some of the ways, with some of the challenges with computer vision and some exciting applications, and I'd love to hear a little bit more about all the stuff Deci has been working on around it. So I know you've
mhm,
had so many cool launches, even just in this last year. Is it this
yeah,
year even that Yellow NOS came out too? Because I feel like every
yeah,
couple months I see like viral computer vision videos coming out from Harpreet and Deci doing really cool
yeah.
things. So like you had Yellow NOS come out, you had
Mhm.
data gradients, and then just 2 days ago, like I was saying too, you came out with a large language model called
Yeah,
Decicoder. Could you touch on at least those awesome three things? And if not,
yeah,
obviously tell us more too, if there is.
yeah, definitely, dude. So just one kind of second overview about Deci is like Deci's like proprietary. Like we've got the open source component, but the thing that we do to like to make revenue is we have a proprietary neural architecture search algorithm, and we call this the AutoNAC engine. And so using the AutoNAC engine, we're able to uh, perform neural architecture search. So, what is neural architecture search? It's searching through a vast search space of possible neural network configurations to find the network that is going to be optimized for a particular deployment environment that meets some constraints. And that particular deployment environment is like hardware. So, it's hardware aware neural architecture search. And the constraints are, the ones that we discussed: accuracy, latency, throughput, so on and so forth. Um, so we've got an algorithm that is able to find the best model for your deployment environment. So that's kind of like the paid component. And so we've used the AutoNAC engine to build a number of models, uh, which have historically been closed sourced. And these models are, uh, you know, state of the art in terms of the results they're achieving. Right, one of them is our Deci Seg, which is our segmentation model. That one's closed source. Another one is Deci BERT, which is taking the BERT model and making it faster. But now we've been venturing more into open source, right? So it started with YOLO NAS being launched in May of this year. And so YOLO NAS is an object detection model, and it's optimized to run on the T4 hardware, and it's a new state of the art on the Cocoa benchmark, and it's beating the OLV5 and the OLV8 in a lot of those benchmarks, including a lot of uh, data sets on RoboFlow 100. Um, and YOLO NAS actually lives in our open source library, Super Gradients. So Super Gradients is a computer vision training library that has like a robust model suite. So it's a PyTorch based training library, and it just abstracts away a lot of that boilerplate code, but then also has a lot of really cool tricks, training tricks that are built in that you just need to run one line of code to run. So, for example, you can really quickly use exponential moving average or precise batch norm or um, blinking out now. Zero weight, zero weight decay on batch norm and bias, things like that. But then it also allows you to really quickly do like knowledge distillation, quantization aware training, uh, and like I mentioned, the models, these 40 something models. So super gradients in a nutshell, and then there's data gradients, which is kind of like EDA for computer vision. And so that's the one we launched. I can't remember now. I think it might have been June or July that we launched it. And now we're kind of venturing more into generative AI. So I mentioned before, historically it's been computer vision and stuff, but our technology isn't limited to computer vision. It could work in generative AI. And so we used our AutoNAC engine to discover this code generation model called Decicoder. So that's right there on Hugging Face. It's actually been trending on Hugging Face since we launched it yesterday. So check it out, Deci Coder on Hugging Face. Give it a heart on Hugging Face and check out the demo. But we're actually going to be releasing a few more models in the coming months. I believe one or two even this year. And we're talking about like generative AI models in something similar to diffusion and something similar to Llama 2.
I'm so excited to see those. I know that, again, I'm sure I'll see them because they'll go viral as soon as you launch them. Especially, I can imagine the diffusion
Cool.
model. I'm very excited.
Yeah.
But that's so cool. And so the core part of Deci, I'm sorry, what was it called? The NAC engine?
The auto NAC. Yeah.
Auto NAC. So
Yeah.
that's almost like you could think, I assume you use some ML or something in the back end. It's kind of like AI helping build AI. So if you're
Yeah.
like, hey,
Yeah.
I need to build an AI model, here's what I'm trying to do. Here are the
Mhm.
constraints. How can I make this better? And it will automatically figure out a better neural architecture that can run on your whatever your constraints are. Right?
Yep.
That's kind of the gist of it. That's so cool. I
Yep.
love like
Yeah.
this loop of AI helping AI. I think is really interesting,
Yep.
and we're just gonna keep seeing more of that. And obviously, wonderful results at Deci.
Yeah. Yeah. I mean, definitely using deep learning to build deep learning models.
Yeah, that's a fun trend.
Yeah.
um,
There might be some XGBoost in there somewhere too, but mostly deep
right.
learning.
Not
Yeah.
everything is always deep learning all the time.
Yeah.
Uh,
Yeah. Yeah.
or it might be like a deep learning model with another model. It is
Yeah.
easy to kind of think about I don't know, using like when people get started with ML right now too, I feel like it's easy to just be like, oh, cool, deep learning does everything, but you don't always. In this case, you might, but you don't always need deep learning for every single ML problem.
Yep. Yep.
Awesome, super cool to hear more about it, and links to everything is in the description. I think that you talked about, including Decicoder. I just added it because I was like, oh, a new thing. I got to add that to the
Awesome.
show notes for everyone.
Thank
All
you.
right, so are there any trends outside of computer vision, like we've been talking about today, in the field of data and ML that you're really excited about?
Yeah, so I've mostly been interested in working with language models, specifically like agents. So AI agents is the thing that I've like really been most interested in learning about and trying to build with. Um, like so when it comes to like LLMs and things like that, like I don't care too much about the math, to be honest. Like it's there if I need to delve into it, but that's not like the thing I'm most interested in. I'm most interested in their capabilities and how I can use it in my everyday life. Um, so that's like the thing I'm most interested in is how do we use these language models, these AI agents to just build tools for ourselves to make our lives easier.
Yeah, I think that's really exciting. I've seen some amazing demos at meetups and stuff recently with agents people have built
Mhm.
to solve a tool or one of the cool things about a lot of agents is them just creating ways to solve those problems. So you're like, hey,
Mhm.
AI, here's the problem I have. I need to do this task, and it can automatically figure out a way to do that task. And even if it gets like 80% of the way there, and then you need to adjust the code a little bit, I think it's really exciting.
Yep, absolutely.
And I know we're a little bit over time. Hopefully that's okay on your calendar. I don't know if you need to run
Yeah,
the second,
no,
but
no, I'm good.
before we wrap up, I just want to make sure. Is there anything else you want to share about your work with Deci? Any upcoming events? I know you also do like awesome events like every week. I feel like you're streaming with
Yeah,
someone really cool in the industry, or just any
yeah,
other topics you want to mention.
yeah. So like that's like kind of my bread and butter is events. I just love hosting virtual events and just like coming together with community. So if you don't mind, yeah, I'll shout out some of the events. So in the Deep Learning Daily community, this our Discord server, every Friday I do a hacky hour, and so the hacky hour is an opportunity, and they're hosted only in Discord. It's an opportunity for someone in the community to show off a project they've been working on. So this week we got one of our community members, Louis Riera, and he built this kind of like computer vision UI where he's like using his webcam and hand motions to control his computer. So he's showing us how he's built that. Next week I got somebody for the hacky hours talking about how to use Dino V2 for downstream tasks. So and then first week of September, we're going to explore the lava repo together. So Friday hacky hours, a lot of fun. community participation is encouraged. But yeah, definitely other events as well. So I've got a series, builders of Yellow NAS. I've got a couple people lined up to show projects that they've worked on using Yellow NAS, and then a bunch of like generative AI um, discussions, mostly around LLMs in production. The end of this month, the 31st, I'm teaming up with the AI Makerspace, and we're going to use Llama V2 plus some movie review data from Barbie and Oppenheimer to do some fun stuff. So we'll be building something cool, hands on. With that, speaking to somebody from the community, Jaita, about her experience deploying language models in production. My friend Abby Arian is writing a book on LLM ops, so we'll be talking to her. Suhas Pai also writing a book on language model applications. We'll be talking about that. So yeah, a lot of cool events. That's kind of like the heart of the community, is just learning sessions like that. So if that's what you're into, Deep Learning Daily, come and hang out.
That's awesome. Yeah, and I have the link to Deep Learning Daily Discord in the description as low, like I meant below, like I mentioned. So if people want to go join that, you can do that, and also follow Harpreet on LinkedIn. I know you post a lot about these events, so that's a good way to keep up with them as well. I'm really
Yeah.
excited for the LM Ops book as well. I forget the release date on it, but I was like, ooh, I'm gonna read that when it comes out.
Yeah. I think, I'm not sure when Abby's book is being released. Probably sometime later this year. Suhas Pai as well. Chris Lexiak, a community member of ours, he's writing a book, LLMs and LangChain for Manning. And he's an active member of the community as well. So check out Chris on YouTube as well. He's got some awesome videos. But yeah, man, community is a great way to learn. Like I love it. Like it I'm in a boot camp right now. Actually signed up with my hard-earned money, not even paid for by the company, to sign up for the LLM Ops Bootcamp with the ML Makerspace, and it's just intense, man. Those sessions, like, got at least I think 7 hours in class a week, plus homework, and
Wow.
just building with the community together, and just having a place to learn is awesome. So, yeah.
That's awesome. Well, we're going to go ahead and wrap up the stream. Thank you again so much, Harpreet, for coming on. Really awesome to hear everything about your history of getting into machine learning, but also about what you're currently working on at Deci. And I'm excited to jump in and try out some of those tools. And all the open source stuff too, I recommend everyone going to, like Super Gradients, Data Gradients, and give it a star. Anytime something's open source, everyone always appreciates a star. I know that from experience.
Yes. especially developer advocates whose jobs are on the line here. If you want us to keep our jobs, go and heart and star our
So if you want
repositories,
Harpreet to keep
please.
doing cool hacky hour events and
Keep
having
us
guests, you have to
employed.
give them a star. So
It don't cost nothing. Just go smash a star, yo. Just go smash a star.
Awesome. I'm gonna go ahead and hit end on the broadcast. So it'll maybe take a few seconds, and but